lot of stuff in it. It's all things related to functions. So it's definitely not a one-day thing. We'll probably start it today, and then depending on how it goes, I'll either teach the whole thing and give you guys a work day on Tuesday, or split it up and teach part each day. But it's kind of a 2-day thing. So starting out with just some definitions. A relation is just any correspondence between two sets. Okay, we're used to thinking of ordered pairs in math, but it doesn't have to be. It's just any two things that are related. In terms of an ordered pair, x is our input value, which we call the domain, and y is the output, which we call the range. A function is a specific type of relation where each input gets exactly one output. So if I said x plus 2, that could be a function. Because when I take a number and add 2, do you ever get more than one answer? No. Every time I do 3 plus 2, I get 5. It's not like I'm going to do 3 plus 2 today and get 5, and tomorrow 3 plus 2 will be 6. So I'm only getting one answer. That makes it a function. So first thing, just looking at some different ways we might see relations. We might see just a table of values. We might see a list of ordered pairs, a mapping, an equation, lots of options. I want to take a look at some of them and decide if they are a function. So key to function just means x doesn't get repeated. So is the first one a function? Yes. The domain. Domain refers to the input or the possible x values. Since we only have those 4, we're just going to put them in a solution set. So the domain is 1, 2, 3, 4. What would the range be?
3, 4, and 6.
Right. The 3 gets repeated, but you don't have to list it more than once. And if your numbers are out of order, that's okay. We like to put them numerically, but if you miss one and put it at the end, it doesn't matter. Is B a function? No. Why?
Because 3 repeats.
Okay. But even though it's not a function, it's still a relation. We could still do domain and range. What's the domain?
1, 2, 3, 4.
The range is a little bit trickier. I have a mapping, but does anything use the -1? So the range, the only ones that get used are 1, 4, and 7. All right, you guys do those two. Set of ordered pairs, decide if it is a function, give the domain and range. So is the first one a function? Yes. You don't repeat any of our x values. Domain would be
1, 2, 3, 4.
range.
4, 5, 6, and 7.
All right, D, is that one a function? No, because the -3 repeats. Domain, the x's that get used. Good. The range, the y's.
0, 1, 4, 8, 9.
Perfect. All right, so in any of those representations, table, mapping, list of ordered pairs, it's pretty easy to decide domain and range if something's a function or not. Let's look at another option. What if I give you equations? It's not as clear cut to decide if it's a function or not. How could we? Or do you have any ideas? Do you think it is or not? If I take a number, multiply by 2, and subtract 5, will I get more than one answer? No. So what does that mean? It's a function. Domain. What could you plug in for x? Or can we do positives? Can we do negatives? Can we plug in 0? So if we can put in anything, we say the domain is negative, then do the positive thing. The range is referring to the answers we would get out. So if I put in something, is it possible to get a positive answer? A negative answer? 0. Yeah. So our range is also negative infinity to infinity. It might be easier to look at a graph on some of these, and we're going to talk in just the next 2 slides about how to look at a graph and get those as well. B. Would that be a function? So, it wouldn't. Why not?
Just the y squared.
If you think about, if I put in 1 for my x, then what would y have to be? Y squared is 1 minus x squared, right? Mm-hmm. But if I put in a 2, I'm going to change this just for the sake of my example here. We'll switch that to a minus, just so I can work this one. If I put in a 2, then y squared would be 1 plus 2 squared is 4, so it would be 5. How would you get y by itself? And when you add a square root, what do you have to add? So that really gives us 2 solutions. That means if x is 2, y could be a positive radical 5, or if x is 2, it could be a negative radical 5. So it is not a function. Another way to think about that without doing the order pairs is just solve the equation for y, get y by itself. If you have to add a plus or minus, then it's not going to be a function. Alright. I didn't ask for domain and range on that one. I did on the previous just for fun, but is this okay? Let's practice doing domain and range by looking at a graph. So if I look at this one, this graph is just 4 ordered pairs. So my domain is just those 4 x values. So that would be the range would be the y values of those 4 ordered pairs. So -3, -2, 3, and 4. B. If I want the domain of this, domain is your possible x values. So I always tell people think traveling along the x-axis, so we're going to go left to right. So if I start at the left, okay, if I think of it as I have this line, as I'm moving it in from the left, what's the first place we hit an x value? At -1. We do hit it, and then it's continuous after that, so we're going to have to give an interval. So it starts at -1 because we actually touch it, it gets a bracket. And then as I keep traveling, when do we stop? At 5. So we -1, comma 5. And they both get brackets. Range is referring to your possible y values. So when we're doing those, let's start at the bottom and go up. So as I'm going up, the first y value we hit is comma. The last y value we hit, positive 2. All right. What are we doing next? So my domain. We have to think about as we go from left to right. This line keeps going forever. Is there anything we don't hit? No. So what do we put for the domain? Range is your y. So keep in mind, this end's going down and that end's going up. So what do we hit for the y's? Infinity always gets parentheses. D. If I look at that one, domain from left to right, so keep in mind it's parabola. Those ends keep going forever, so what's the domain? As it goes on, it's just going to keep spreading out. The range is talking about your y values. As you are coming up from the bottom, the lowest y value we hit is 0. And then it keeps going up forever, so we hit everything after that. So it'd be a bracket 0, comma, infinity. All right, do you know how to look at a graph and decide if it's a function?
Isn't it like crosses the x-axis more than once? It's not a function.
Close. It's not the x-axis, but it satisfies the vertical line test. So what it means is if you can draw a vertical line and it hits your graph more than once, it's not a function. So every vertical line can only hit the graph at most one time. All right, if we look at these, were all of them functions? Which one was it?
The circle.
Yeah, because you can take a vertical line that hits it twice. All right, so you guys take a look at these graphs, decide which ones are functions. Take a second on your own. Tell me. Yes? So is this one?
Yes.
Is this one?
No.
No, vertical line hits it more than once. This one?
No.
And this one.
Yes.
All right, are we good with that? So when we're talking about domain, we can get it from the graph, we can get it, if we have a mapping, we can get it from that or the table of values. If we're just looking at the equation, what do we have to look at for the domain? Or what would make the domain not be everything? When you think of a scenario where there's something you can't plug in for x. What about when we have fractions? What can't happen in a fraction? There's one number we can't divide by. Mm-hmm. So in a fraction, the denominator cannot be 0. The other thing we need to worry about are even radicals. So by even radicals, I mean like a square root, 4th root, 6th root, and so on. In those, the radicand, which is the thing under the radical, has to be greater than or equal to 0. that okay? So if we look at these, without drawing a graph or anything, we might be able to decide what the domain is. Now we already talked about it for this one just by reasoning through, but does it have a fraction? No. Does it have a radical? No. So my domain should be negative infinity to positive infinity. Let's compare that. Let's look at a graph. So any of these, we could also look at a graphing calculator to kind of help us out. If you look at it, well, this one we probably know. What's the graph of? It's a line. The y-intercept of -5, slope of 2. And so we can see pretty easily then it's a function. Domain is everything, range is also everything. Alright, what about this one? Y equals x squared plus 3. Domain is all the possible x values. Why don't you take a look at this graph? What's it look like?
It's a problem.
Parabola is just been moved up 3. So is that a function?
Yes.
Yeah, passes the vertical line test. Domain,
Be 3 to infinity.
that's your range, yeah.
Yeah. It'll be negative infinity to infinity.
Good. Alright. See. Is this one going to be a function? A little bit weirder. Can we even graph that on the graphing calculator? No. Okay, so let's say if I wanted to graph it, so I'd have some idea, we could always do it the old-fashioned way, make a t-chart. If I put in a 0 for my y, I'm going to plug things in for y since it's inside. Absolute value of 0 is? If I put in a 1, negative 1, 2, negative 2. Okay, let's graph them. 0, 0, 1, 1, 1, negative 1, 2, 2, 2, negative 2. We took the absolute value graph and flipped it on its side. So is it a function? No. Domain, going from left to right.
From 0 to infinity.
Range would be
From negative infinity to infinity.
Alright, couple more of these. If I look at this one, y equals x, what would that look like?
Just a line.
Yeah, y equals x would just be a line. I guess it's a negative x, but that's just a line. Negative slope. What does the greater than do? We haven't talked about that this year, but you have last couple. Remember how you graph inequalities?
Would you like shade?
Yeah. So if I shade, is this a function anymore?
Yeah.
No inequality is going to be a function. So as soon as you see that greater than or less than, it's not a function. Domain and range would both be negative infinity to positive infinity. last two of these. E. We should be able to look at that and know our domain based off what I already told you. If it's a fraction, we know what?
The right to that is not.
So I know the bottom, x plus 2, can't be 0. So x can't be negative 2. Look at this one on your graphing calculator. Put the x plus 2 in parentheses when you go to graph it. Alright, so looking at that, you kind of have a break in your graph at negative 2. We have a piece below before that and a piece above after. So our domain is everything except the negative 2. Is this one a function? Yeah. So for the domain, we would say negative infinity to negative 2, union negative 2 to infinity. Everything smaller than negative 2 and everything bigger than negative 2. The range is referring to your y values. If you look at this, starting at the bottom, where is it coming from? And then, where do we have the break in the graph? At 0. At the x-axis is when we have that break. So it's negative infinity to 0, union 0 to infinity. All right. Last one. If we have a radical, what did we say about those? Has whatever's under the radical, since it's an even radical, has to be greater than or equal to 0. So, because we have a negative under a radical, that gives you an imaginary number. So for x plus 1 greater than or equal to 0. So if we subtract the 1, divide, x is greater than or equal to negative 1/4. Look at the graph of this one so we can kind of figure out the range. Kind of get something like this, don't you? So it's a function. Domain, we can see it starts over here, but we already know that's negative 1/4. And it goes on forever. The range is your y, so our lowest value is 0, and it goes up forever. So 0 to I think I'd like to do just a couple of the slides on function notation, and then we'll stop there and pick up next week. That way Megan won't be too far behind either. So the last thing we're talking about, function notation, that's that f of x that you've seen before. Just remember, f of x represents the y value. So when you see f of 2 equals negative 13, the x is the 2, the y is negative 13, or that's saying the ordered pair is 2, negative 13. So make sure you can keep those x and y separate. If I give you some functions, when I ask you to find f of negative 3, what am I asking you to do? F of negative 3, I'm basically saying find your y when x is negative 3. So we go, f tells me it's function f. You replace all of those x's with a negative 3. Okay, have to be a little bit careful here. Negative 3 squared is 9, but the other negative in front of that would make it a negative 9. Negative 6 times negative 3 is positive 18. Plus 4 plus 2. So that says you go to function g, and we replace the x with an r plus 2. So if we distribute, we get 3r plus 6 plus 1, or 3r plus 7. Good on those two? Last slide. I just want to look at some different representations for our functions, and we're going to find f of negative 1 in each of these cases. So remember, when I'm saying find f of negative 1, that's saying x is negative 1, find y. Why don't you guys take a second and see if you can do it for each of these. -7 for the first. Second one, we're looking for the point when x is negative 1, and we need the y value. So that should be a 6. Third, the point when x is negative 1, give the y value, so that one should be 5. And the last one, we're looking for when x is negative 1. So the point on the graph when x is negative 1 is about right here. What's the y value of that point? Alright, any questions so far? So if you flip to the very last page, I put all of the homework for this section. So you can use the next 15 minutes to work on that. Tuesday, it's no school Monday, I'll finish the notes and you'll have class time then.